Have you ever looked up at the moon and wondered about those mysterious craters? What if we told you that they could be the key to unlocking new frontiers in space exploration? The moon, our closest celestial neighbor, is home to a staggering 1 million craters. But these craters present a challenge. How do we accurately map the moon's surface when our trusty GPS satellites orbiting the Earth can't reach it? This is where Sophia McLeod comes in, a doctoral candidate from the University of Adelaide. Her eyes are not merely on the moon, they are on every single crater that decorates its surface. Sophia has taken on the formidable task of mapping these craters, not deterred by the lack of GPS or the daunting number of craters. Imagine each crater as a unique fingerprint, a distinct feature that can be used as a reference point. Sophia is using these lunar fingerprints to create a map like no other. A map that could redefine the future of lunar missions. Sophia McLeod is not just staring at the moon, she's transforming our understanding of it. So how does one go about mapping 1 million craters on the moon without GPS? Sophia McLeod has a plan. Imagine trying to navigate a landscape riddled with 1 million craters, but without the luxury of a GPS. Sounds impossible, right? Not for Sophia McLeod, a doctoral candidate at the University of Adelaide. She's taken on the audacious task of accurately positioning future geological survey data of the moon's surface. Now, you might be wondering, how does she plan to do that? The trick is in the pictures. Sophia proposes using images of the moon's surface to identify and map craters. These craters, scattered across the lunar landscape, then serve as reference points to triangulate the satellite's position. It's a bit like using landmarks in a city to figure out where you are, except the city is the moon, and the landmarks are craters. But how do you spot craters in a sea of grey lunar rock? Enter machine learning. Sophia employs this advanced technology to sift through images and detect craters. It's akin to finding a needle in a haystack, but on a cosmic scale. However, spotting the craters is only half the battle. Sophia then uses classical computer vision techniques for matching and positioning. This ensures that the craters identified by the machine learning process are accurately mapped and the satellite's position correctly triangulated. The accuracy of this mapping is absolutely crucial, not just for the sake of academic curiosity, but for practical purposes too. Future lunar missions depend on this precise mapping for safe and successful navigation. Miss by a few meters and it could lead to catastrophic results. Sophia's method is not just about the moon, it's about paving the way for drone landing and autonomous vehicle navigation here on Earth. With her innovative approach, Sophia is not just mapping the moon, she's charting the course for the future of navigation, both in space and on our home planet. The moon's craters, once considered just a part of its enigmatic beauty, are now proving to be much more than that. Sophia McLeod's research is revolutionizing our understanding of the moon and its craters. Through her innovative use of machine learning and computer vision techniques, she's mapping the moon's surface with unprecedented accuracy. But the implications of her work extend far beyond the lunar landscape. Her methodology offers a new way to navigate in space where GPS satellites are ineffective. By using the moon's craters as reference points, we can triangulate the position of satellites with precision. This breakthrough has significant implications for future lunar missions, making them safer and more efficient. But that's not all. The techniques Sophia is perfecting have applications right here on Earth. They could be used to improve drone landing and even autonomous vehicle navigation, making these technologies more reliable and accessible. The moon's craters, through Sophia's work, have become our guideposts in space, helping us navigate the final frontier with precision and accuracy. To continuously be enlightened, like and subscribe.